Welcome to the FMSP online revision. This session is for AQA M1. Topic is kinematics and we're looking at question 7 from June 2011. So if we start by having a look at the question. So we've got a helicopter initially hovering above a lighthouse. Now just notice the information that you've got there. It's initially hovering, so that means that the initial velocity is 0, and that's some information we will need later. It then sets off so that its acceleration is given by the vector 0.5i plus 0.375j meters per second squared, and it does not change its height above sea level, and the unit vectors I and j are directed east and north respectively. And three things we've got to do. First of all, we've got to find the speed of the helicopter 20 seconds after it leaves its position above the lighthouse. We've got to find the bearing on which the helicopter is travelling, and be careful, we're asked to give it to the nearest degree, and it must be given as a bearing. And then in part C, we're told that the helicopter stops accelerating when it is 500 metres from its initial position, and we're asked to find the time it takes for the helicopter to travel from its initial position to this point where it stops accelerating. So we'll start by just reminding ourselves, I've put up here that the acceleration is given by this vector. We'll remember that the helicopter is initially hovering. So we're just going to see if we can find the speed. So the fact that it was hovering initially means that u equals 0. We're asked to find the speed after 20 seconds, and we've got a vector for its acceleration 0.5i plus 0.375j. And in order to find the speed after 20 seconds, what we will need to do is to find the velocity vector. And of course the equation which connects the velocity vector's final velocity with acceleration time and initial velocity is going to be v equals u plus at. So that's the equation that we're going to use. U is 0, so all we're going to do is we're going to take this acceleration vector 0.5i plus 0.375j, and we're going to multiply it by 20. And if we do that, we end up with 0.5 times 20, so that's 10i plus 7.5j. So now effectively we just need to find the speed. So it's gone 10 across and 7.5 up. So we could think of it in terms of triangles, we can think of it as 7.5 upwards and then 10 across. Or you can think of it as 10 across followed by 7.5 up. But remember, you're adding nose to tail. And if we just continue over here, then working out the speed, then we're using Pythagoras theorem, so it's just the square root of 7.5 squared plus 10 squared, or the other way around, and that works out to give a speed of 12.5 meters per second. So that now is the answer to part A. And if we have a look now at part B, notice it says to find the bearing, so we must give it as a bearing and we must give it to the nearest degree. So either of these diagrams, but this one, remember that a bearing is measured from north, so this one is probably the easier one to use, but either. Just be careful though that you are making sure that to give it as a bearing. So in this particular case, tan of alpha will be equal to 10 over 7.5, and if you use that information, that tells that alpha is 53.13 degrees. Now again, we're giving it as a bearing, so the bearing to the nearest degree is going to be 053 degrees. If we now move on to part C, we're told that the helicopter stops accelerating when it is 500 metres from its initial position, and we're asked to find the time that it takes to get there. Now, there are lots of different ways in which you could approach the question, and there are different ways, as I say, and it doesn't matter which you choose. But I've got the acceleration vector up here, so what I'm going to do, because we're told that this is just a distance here, 500 metres, I'm going to just work out what the magnitude of the acceleration is. So 0.5i and 0.375j, so that will be 0.375, and this would be 0.5. Now, if we use Pythagoras' theorem to find the magnitude of the acceleration, then that will just be 0.5 squared plus 0.375 squared, and that gives us 0.625. So we now have the magnitude of the acceleration. So what we could do, and we have a distance, so we have, we know that it started off with an initial velocity of 0, so an initial speed of 0. We know that the distance travelled is 500, and now we have a magnitude for the acceleration, 0.625. So what we could ask to do is to find the time. So we're now, if you like, just using s equals ut plus a half at squared, but we're not working with vectors anymore. So just bear in mind we are now working at scalar quantities. So s is 500, u is equal to 0, and so we then just have a half times 0.625 times t squared. And if you simplify that out, that will give you an answer of 40 seconds. So it was what, 1000 divided by 0.625 will give us t squared. And as I say, then take the square root and you get 40 seconds. Now, as I say, there are different ways in which you could do that question, but I think in many ways that is probably the simplest of them. But don't worry if you've got an answer of 40 seconds, as long as you've used a correct method, then that's the main thing. So if we just go back and have a look at how the marks were given for that question. So in this first bit, so there were 4 marks for part A. You got a method mark and an accuracy mark for finding the velocity vector, the final velocity vector, and then you got a method mark for finding the speed, but that method mark was dependent on you getting the method mark up here, and then you got an accuracy mark for finding 12.5 meters per second. In this one you got a method mark and an accuracy mark for using the tan of the alpha equals 10 over 7.5, and you got an accuracy mark for giving it as a bearing. So unless you gave it as a bearing, you won't get full marks. And then part C, and the last one in part C, then you get a method mark and an accuracy mark here, doing it this way for finding the magnitude of the acceleration, and then dependent on this method mark you'll get another method mark here for using s equals ut plus a half at squared, and substituting in that correctly will give us an accuracy mark, and then another accuracy mark for finding 40 seconds. So 5 marks for that part, 7 marks for parts A and B, so 12 marks in total for that question. So don't forget that you can access further revision videos by going to the Further Maths Support Programme website and following the link.